Welcome to my talk on becoming more juicy. This is the second talk of the series of indefinite length. If you were not at the talk that I gave about a month ago and you haven't watched it on Google Video, you might be missing a few of the fundamentals that I'll just be glossing over here. Hopefully it won't be too bad, but you can always go look it up on Google Video and give it a viewing. Or maybe you're seeing me on Google Video right now. Stop, go to the other video, watch that one first. In this talk, I realized there is a lot of demand for a talk that would be sort of a recipe-based approach of, take this situation, you want to do this, how do you do it, change the code. I am working on putting together a talk or a series of screencasts on that subject. That's not actually the approach that I'm taking today. So the approach that I am setting out to accomplish here is to try to give everyone, to the best of my ability, a good mental model in your head for how Guice thinks and how Guice behaves and what it's doing behind the scenes. I'm lucky enough to be one of the only 2 or 3 people who have been using Guice for a full 9 months, maybe, I'm not sure. So I've had a lot of time to build up this nice mental model in my head so that makes it so that people can ask me questions about what will Guice do in this case, or how should I tell Guice I want this? And I'm able to pretty much figure out what it'll do and answer the question. So I'm going to attempt the impossible. I'm going to attempt to sort of try to convey to you sort of how it works. And it's sort of like in high school when you had chemistry class, you always had to have 4 days of boring lecture and then 1 day of lab. So maybe the next lecture will be lab. Any questions on that? And we'll try to cover the injector in some depth, scopes in some depth, a few words about testing, and I'm going to drop some teasers about what Bob and I are working on for Guice 2.0. And whenever you do have any questions, you can put your hand out, and the gentlemen over here have a roving microphone that you can use. Okay, so here's the standard setup. This is taken right from the previous presentation. You have an interface. You have something implementing that interface. You have somebody who needs something of that interface. This is garden variety vanilla Java code with an add inject inserted. And on the next page is the glue that we use to take Guice and juice it all up together so that it runs. We looked at this in the last talk. We have a module that instructs Guice for this type displayer. We want to use this implementation, standard out displayer. And then we have our application, which is these 3 lines of code. If you put all this into your IDE and run it, it should actually run, unless I made a typo. It's a complete Guice application. This is just sort of review, so if anything here is confusing already, we should address that sooner rather than later. I want to talk for a bit about the Guice injector. One thing that you noticed very quickly about Guice is that it has nothing called container. If you've used Nano container or Pico container or the Spring IOC container, we deliberately did not use the term container with Guice. To me, the idea of a container is that it's something that's larger than your objects. It's something that your objects have to live inside, and your objects may not be able to function properly if they're not inside that container. What Guice does is really very different. It performs a task for you. Its task is to fulfill injection requests. You ask it to inject things, it injects them for you, and then it's done, and it gets out of the way. In fact, if you were to, well, actually, what I was about to say, I'll say a few slides later so I don't confuse you. So its sole purpose is to fulfill injection requests, and it does that, yes? I'm sorry?
It does pull out the singletons, though.
So Guice comes with bundled scopes,
okay.
And those bundled scopes do things like hold on to references, but they're sort of separate from the core Guice engine. So yes, there's probably a million asterisks that we can say, well, Guice also does this. But I just want to drill in the point that this is basically its purpose in life. So what is resolution? There we go. Okay. So resolution is simply how we get from an injection request to some instance of something. And an injection request usually looks like you have add inject, and it's applied to a field or a method or a constructor. And Guice takes that and it says, OK, I know that you're looking for something like this. I've got to eventually get to an instance of that. What the resolution process does is it gets from that request and it finds the instructions that you have configured for how you want that to be fulfilled. And there's really three fundamental ways that Guice can do this. You might have given Guice a single instance from your module at the beginning, saying always use this instance. You might have given Guice a class that Guice will instantiate, or you might have supplied a provider. The first thing that it does to fulfill an injection request is it figures out what your key is. So if you have add inject foo, your key is simply the type foo. You may also have an optional annotation on that injection. So the key is really the combination of the type and the optional annotation. Then, as we've seen already, you can have bindings in your modules that sort of give Guice instructions for how to get closer to the goal. If you wanted to, you could set up an elaborate chain of bindings. If you have a class called foo that has a subclass subfoo and sub-subfoo and sub-sub-subfoo, you could bind all of these things to each other one in a row. Guice will just follow them all down. Sometimes this actually turns out to be handy. Sometimes it doesn't. But Guice will transitively follow all of the bindings that you have until it winds up at a binding that is sort of an endpoint of this process. And if we came to an instance or a provider reference, we are done because we have basically come up with the complete finished sort of instruction for how you want to instantiate this class or how you want to obtain this instance. If when Guice tries to resolve your request, it ends up at a Java type that it doesn't know anything about, it's going to look at that Java type. And I don't have code examples for this, so I'm just going to gloss over it. You can optionally put special annotations on a Java interface or class, telling Guice either what that class is implemented by or what that class is provided by. But you don't really have to do this because most people prefer to use the modules. But it is there. When Guice sort of finishes following all these hints, it ends up at some type. It's going to assume that it can instantiate that type. Clear as mud. So at this point, it knows how you want to create that instance. Actually, OK, this is indented wrong. But if it found that for type foo, you had passed in at the beginning a new foo, paren. It already has the instance, so it's done. There it is. Just gives you the instance. If it's at an instantiable class, it instantiates it, and it recursively has to fulfill the injections for that class. And if it has wound up with a reference to a provider, it basically has to repeat the resolution process all over again. It resolves the provider, and when it's all done with that, then it calls get on that provider, and that's how it gets the instance. Some of these are subject to scoping that I'm going to be touching on soon. So now we've figured out how we should obtain the instance, and we have obtained the instance. And now in most cases, all that is left is to inject the value by setting the field or collecting up all the parameter values and calling your method, calling your constructor. This also might have been a request that you pulled from Guice because you can call injector.getInstance and you can call provider.get. And in that case, it just returns the instance to you. It doesn't have to actually inject it anywhere. Yes, please.
Suppose I have a base class and another class that extends it, and they both have injections. So I'm trying to provision the extended class. Is Guice going to travel up the inheritance chain and also look at the superclasses and inject them properly?
Yes, it does. Does it also grab private members from superclasses? Probably not. But private members from superclasses are not inherited. So, but it still does. Okay. Okay, but that answers your question then, I guess. Okay. So that's one of the things that's actually handy about method and field injection is that you can put them on a base class, and then your subclasses don't even have to know about them. Okay. So some of those details were probably clearer than others. Some of them were maybe a little bit muddy. But at least I hope that you have a little bit better of an understanding of what Guice really does. It sees injection requests, it resolves them, it provides the instance, and then it takes that instance and injects it. And that's pretty much its only job. So that sort of tells you how things work on this nice microscopic level, which is nice and easy to understand. But obviously, several of the steps in what I just described are highly recursive in nature. In order to construct a class, it might need injections of its own, and in order to get those, they may need injections of their own. And one of them may need to be provided by a provider, which needs injections of its own, and so on and so forth. So every time that you ask the injector for an instance, it may be actually creating a very large graph of objects and very quickly and returning that whole graph to you. In fact, it could, in certain situations, actually create the entire object graph of your entire application all at once. There are a couple of things that actually prevent that from happening, which I'm going to explain next, which are provider injection and injector injection. But if you never used those features, what would happen the second that you, in your main method, that you asked for one instance from Guice, it would create the entire graph of everything you need. And if you took that instance and you discarded your reference to the injector would actually get garbage collected at some point. It has served its purpose and it's finished. In reality, that usually doesn't happen because you're going to use typically some of these features like provider injection and injector injection, which I'm explaining next. So this is a slide whose font is too big. Okay. So this example is, again, pulled right from the previous talk. Anytime that you can inject a reference to a foo, you can always choose to inject provider of foo as well. You don't have to do anything special to enable that, and it always is recognized by Guice that what you want it to do is to inject into you some handle, some object that you can call get on to obtain what you really want. Basically what this does is it tells Guice to not be as eager as it usually is. So don't go ahead and create this gigantic graph of 10 million objects just because I wanted to get the help message of my application. Only once that method called get gets called, that may touch off, a further instantiation of another branch of this big graph. So if you imagine, as I'm trying to reason about what's happening in real life at runtime in my application, I'm seeing these huge graphs getting just sort of with every request created and thrown away, and there's a core graph that has my singletons and is pretty much there for all time. Does that make sense? So, providers are just a simple, provider injection is just a simple way to delay continuing to instantiate all the stuff down below that spot. And by the way, if you use provider injection and you get an instance from that, and then you retain that instance in a field of your class, then what you're doing is you're outsmarting Guice and its ability to help you, and it's not a good idea. I would not recommend it. Usually you just get the value when you need it, and if you need it again, you get it again. So then we have this thing called injector injection, which it's not even a really advanced concept. It's just simply that the injector will happily inject into you a reference to itself if you want it. Most of the time, you don't want it. But if you're writing some kind of abstract framework that has plugins, like we have web work integration and struts2 integration, this is how they work. They get a reference to the injector injected into them, and then they can do two things. They can just arbitrarily get instances from it whenever they want to. And if they have an instance of something that they got somewhere else that they didn't create through Guice, they can pass it to the injector to say, do some post-injection of the fields and the methods in this object. So it's obviously once the instance already exists, it's way too late for any constructor injection to happen. It's already been constructed. But the field injection and the method injection can still happen. And theoretically, you could take a single instance, call inject members on it, do some stuff, and then inject different members into it. I don't think you necessarily want to do that, but you could. Maybe you come up with some reason why that's valid. So injector injection is a very big hammer. It's something, that will let you do anything you want, and the downside is it'll let you do anything you want. So if you try to reason about what your dependency graph looks like, well, as soon as you have something that has the injector injected into it, it might depend on anything, and you can't tell anymore. One of the big advantages of using the DI dependency injection pattern is that you can just look at the code and you can see the dependency graph. You can see this depends on that, very clearly. Just look for the add inject tags. So I'm going to be moving on to talking about scopes. And I think I pretty much explained everything I wanted to explain on this subject. Does anybody want to ask any questions that are relevant to this? Yes, in the front row, please. Oh, do you want the microphone?
Yeah.
Thank you.
So for the provider injection, do you have to create a class of that provider for that? No? Okay.
No, it's basically, so the provider interface is used in multiple different ways in Guice. One way you can use it is you can create a class that implements provider so that you can control exactly how you provide instances to Guice. But also, even if you don't do that at all, you can simply ask to have a provider injected into your class. Guice will just generate a provider that when you call it has the right hooks to know where to get the instance from. You have to do nothing special. Jesse.
I've heard that the provider is also useful if I need multiple instances of my foo.
So other reasons to use provider injection, thank you, Jesse. One reason is laziness. Other reason is you may want to get multiple instances of the same type, and this gives you a way to just get as many as you want. There is one wrinkle with that, though, which we'll see when we get to scopes. Because somebody might have applied a scope to this binding. They may have declared it a singleton, and if they've done that, you can call get as many times as you want, and it's not going to help. You're going to keep getting the same thing. In the back? Oh, that should be on too.
Okay. Why is it bad to hold on to a reference that you get from a provider? So if you inject a provider into the constructor and then you just set a field to it right away in the constructor and held on to it, can you provide it? Could you give an example of?
So if you're actually able to get the instance right away in the constructor, then you probably could have just done away with provider injection in the first place and just had the instance provided, and that would be more clear. If there's a later point in time when you can get it, I would say holding on to it, if you're going to hold on to it, you should know what you're doing, because when we talk about how scopes work, you'll see that it's possible for an object to be valid in a scope at the time it's injected to you, but if you hold on to it in your object, later on that scope might be dead, but you may still have that reference. So you're essentially just limiting Guice's ability to catch errors before they happen. But if you're pretty sure that you know that it's safe, I'm not gonna find you and come knock on your door. Okay. So, time to talk about scopes. The easiest way to approach scopes is to start by describing what things would be like if there were no scopes. I wanted to get that guy who does all the movie trailers to narrate this for me with that voice that they do with every movie trailer. In a world, and there's one man must rise above and all that stuff. In a world with no scopes, nothing gets reused. Every time anybody needs something, it's created, it's injected, and it's thrown away. So if you were to look at your object graph would be a tree. Because there would just be no way for two different nodes on that tree to both depend on the same instance, because we're just throwing it away every time. All that a scope is a policy for how instances should be reused. We also sometimes use the term scope when we're really referring to a particular incarnation of a scope. So in other words, if you have objects living at a request scope in your web server, then every time a new request comes to that server, there is some object somewhere that's being born and is remembering things for a while, and then the request ends and it dies. These things are constantly being born and dying, born and dying. And we sometimes use the term like, oh, the scope, has ended, so I'm accessing out of scope, or, put that in the scope. And we're really talking about what I'm calling an incarnation of the scope, for lack of a better term. The three canonical examples are singleton, request scope, and session scope. These three are the three that are provided with Guice out of the box. The singleton scope is handled by the core Guice framework. The request and session scope are added by the servlet module add-on to Guice. So you can actually, well, I think I'm going to cover this in the next, I'm going to cover what I was about to say. All right. So does anybody know what T25 is? There's just like this mouthwash called Scope, and it says with T25. And the idea is like, wow, I mean, that's going to get rid of my bad malodorous breath, but it doesn't actually mean anything. So sure, my scopes have T25 too. I'm just declaring that they do. I hope I don't get set upon by any trademark lawyers for this. There are some bad odors that they can address. So one bad odor is the context object. You ever seen this thing that you call like, this is my email context, or my XML context, or my who knows what. And it's full of all these setters and getters for things that are sort of seemingly unrelated, but you just need this catch-all place to kind of put them all and get them later. This is a kind of a smell. Another anti-pattern is the fire brigade pattern. In the olden days, before they had like running water from hoses, what did they used to do? They used to line up and they'd have a bucket of water and they'd pass it to the next guy, and they'd get the next bucket, and they'd keep passing all these buckets down. So I'm sure you've all seen code that calls other code, passes in a parameter, and all that this code does with that parameter is pass it to the next guy, who passes it to the next guy, and nobody's actually using anything on this parameter. They're just passing it all the way down the line because somebody might need to use it down there at some leaf level somewhere. This is another sort of a signal that you could take that object and bind it in a scope instead and save yourself a lot of mess in all these intervening layers. And of course, kind of going along with, the latter two kind of go along with the first one. Another way to handle the fire brigade problem is just having static thread locals scattered all over the place whenever you need them. And maybe you're remembering to clean them out properly when you're done, and maybe you're not, and who knows. If you use Guice and use Guice's scopes, it deals with that stuff for you so that you don't have to. There are two ways that you can apply a scope. Every scope has an annotation that identifies that scope. So in the Guice platform, there's these three annotations. Anytime that you bind something, you can simply say in, and you specify one of these annotations. Or you can put the annotation right on your class if you want to. So what's specified in the module always takes precedence over what's specified on the class. If it were the other way around, then once you put it on a class, you'd be locking that in for everyone, and nobody would ever be able to change it. So that's overridable. We have a question, Ariel. No? Okay.
Is there a warning if you try and scope something, like if time square displayer was request scoped and then you try to scope it as a singleton, and clearly you're using it?
No. So if time square displayer is marked that it's request scoped, and when you bind it as singleton scope, Guice assumes that you're doing this for a reason and that you know what you're doing. It doesn't issue any warnings. There are pitfalls where you can get into trouble, which we're going to get to in a few slides. Okay. What makes these scopes work is not really magical. On the same binder interface that you use in order to bind your interfaces to your implementations, you can also bind scopes. And to use the servlet scopes, all you have to do is add this servlet module that comes with Guice into your injector. And if you use it, the first two things that it does, if you look at the code, is it binds two scopes. And the first parameter is the annotation. The second parameter is just an instance of an object that implements this scope interface. If you wanted to use the request scoped and session scoped annotations in your code, but you're not a web front end and you want to have a different implementation behind them, you can go ahead and do that. You can just bind our same annotations to your own implementation of scope. And it's a little unfortunate that we did put the request scoped and session scoped annotations in the juice-servlet.jar and made it part of that servlet package. But those annotations themselves are really not highly servlet specific. So that was arguably a mistake. And this is just a glance. I'm not going to go through this line by line. But with a few sort of details omitted, this is really the gist of how request scope is implemented. If you look at the real code, there's like some toString methods in there, and there's like a synchronized block, but I just left out the little things like that. That's basically all it does. A scope is something that can take a provider which always creates and return you a provider that sometimes creates. And that's basically it. That's the magic. I won't go into high amount of detail on this, but I just wanted to show you that it's not super rocket science. Singletons are special among scopes. They're the only scope that we currently support eagerness versus laziness for. Everything else is lazy. Just because your request has begun, it's not going to go find everything that's request scoped and just go create those all right from the beginning. But with singletons, we have a mode that you can use when you bind using .asEager singleton, where it will automatically instantiate and prepare and inject all of those instances right away when you create the injector. Two ways of doing it are with the asEager singleton method, and you can also just new it up yourself in the module and pass it in using toInstance. In fact, in the second example, what you're doing is like super eager. A super eager singleton, because even just by virtue of configuring this binder, you're already instantiating your class. You may not actually ever create an injector, but you're already instantiating this class. And one thing to keep in mind with your module class is that it could just as well be some bit of utility code or some tool or some IDE plugin that's executing your module. It may not ever be actually intending to start up an injector and actually serve requests from it. So we tend to sort of not prefer this approach where the module does the instantiation itself, and we prefer to just specify a class and let Juice do what Juice does best, which is create things and inject them. Whoops. But I should point out that even in the latter example, which is sort of not preferred, we do still support field injection and method injection for that object that you give us. So obviously, again, it's too late for us to do anything about constructor injection because you just called the constructor. But we'll happily inject the fields and methods, and we do that as one of the final steps. When you create the injector, just before we return, we go and inject all those things. Okay, so here we get to the tricky stuff. I called this slide Night of the Living Undead, and we'll see why, hopefully, in a second. There is a problem with what I have called backward scope access. In this example, we have a class that lives at some wide scope and has an injected object that lives at a narrower scope. So if you take any two random scopes that exist, it may be that neither is wider or narrower than the other, yet there are plenty of relationships that do have this quality. A singleton scope is always going to be wider than any other scope. Request scope is always going to be narrower than session scope, so on and so forth. When this happens and you make a backward injection, some bad things can happen. And quite honestly, it's a bug that Juice even permits this in the first place. And at the time we released Juice 1.0, we were sort of seeing it as a feature request to be more careful about it. But since then, we've sort of realized just how problematic this is. So if you do this kind of thing, when you upgrade to Juice 1.1, your code will start blowing up right at injector creation time saying you shouldn't do this. Now, here's why. The first thing is, if you're really lucky, it'll just blow up right away, because you may be creating this class during a time when the narrower scope is not in existence. The narrower scope may not have been incarnated yet. You might be in singleton scope doing your server startup, and this thing might be at request scope and no actual web requests have come in yet. So that's the good case, because you get the exception right away. But it could be that nothing actually caused the singleton to load during server startup, and it's actually during the first request that triggers this to get instantiated. In that case, it will fulfill the request, but nothing knows how to realize when that scope, that request scope, has died. So this reference will continue to live beyond when it should have been dead, and that's why I call this Night of the Living Undead. It's kind of an undead reference. So the next version of Juice will be, will tell you what's going on here. In the meantime, you have to be careful. One fix for this, sometimes when you have things injected, sometimes it turns out that you could have just made it a method parameter on some of your methods, and the people who call you can more easily have it injected because they live at a different scope. So that's one way to handle it. Another way is just use provider injection. If you use provider injection, and then you just only get from that provider at the moment you need something, and then you throw away the instance, then you should never have any problems with scopes. Sasha.
So I've been using the provider injection basically as a way of not having to think about this problem. Any reason not to do that?
So the question is, why not just use provider injection all the time so that you don't have to worry about this problem? And the answer is there's really no reason not to do that. It makes your code more cluttered. But other frameworks actually take different approaches to this problem. I believe in Seam, they have this thing where they will insert bytecode in between all of your code in such a way that your fields and methods get injected right before every method call to your object. And when that method finishes, those things get outjected again. Bob can tell me if I'm totally wrong about that. So that's one approach. Another approach is to have your reference to MyNarrow class actually being this proxy object. And the difficulty with, the problem with following either of these is that I think that it makes the structure of your code and what's happening a lot more mysterious. There's a lot more funny magic that's going on. Whereas really with Juice, once Juice finishes injecting everything, then it kind of gets out of the way.
So
Ariel.
if you're using custom scopes, like in a library and somebody else is using custom scopes for the consumer, and Juice is supposed to police who's narrow and who, how does Juice know who's custom scopes?
So the plan at this point is that custom scopes can optionally declare one or more scopes that they are definitively wider than, and they can also declare one or more scopes that they're definitively narrower than. If we have two libraries and neither of them has the dependency on the other, then we have to assume that there's probably no relationship between their scopes either that can be really known. But for example, if I sit down and write a conversation scope, I can easily say, I know that I'm narrower than singleton scope, and I know that I'm wider than request scope.
Is it leading libraries implementations out to consumers then? If a consumer has to know what the library is doing under the covers?
So the question is, does this sort of bleed too much internal knowledge of a library out onto consumers? I do think that the way that scopes work in Juice does require you to have knowledge of whether you're making a downward scope access or an upward scope access, and you have to, unless you do what Sasha suggested and just use provider injection all the time. And so that fact is somewhat unfortunate, and maybe there will be something that we can do to improve that situation. I'm not sure. Yes?
Not necessarily a good thing. It seems like this is roughly the equivalent of creating something called scope local instead of spread local and passing those into every single object in the constructors and then just having random stuff be populated by random things. Is that necessarily cleaner than actually doing some of these things that you're trying to get around?
So the question is sort of a design question of sort of, is the question sort of like, is it worth using scopes as Guice has implemented them when you could do something else instead? Or why weren't scopes implemented differently than they are? I'm not sure I totally.
It just seems like you're encouraging basically passing thread locals, or the equivalent of thread local, but like scope local into objects. And it just seems fundamentally bizarre.
So I can't comment on whether it's bizarre or not, but we found it to be very useful. So
Is it clean and maintainable?
we've found it to be clean and maintainable. Modulo some of these issues with the Night of the Living Undead. Right?
Well,
Okay, Sasha first, and then.
so an answer to that is, you're still, when you're injecting...
Can you maybe take the microphone if you're.
Yeah, right. So the answer that makes me happy is that when you're injecting a provider, you still see exactly what your dependency is, whereas when you're using a static thread local, it's just a mysterious access somewhere. It's not as clean, of course, as just injecting the thing, but yeah.
I'm not allowed to use a static thread locals on this either. It seems a step towards that.
Okay, so this is an example of the kind of question that is great to send to our mailing list, especially with sort of example code like, look how this could work instead, and we read all those and think about them.
There's a big difference between injecting a stateful service and injecting actual data.
There is, yeah.
Supports both. And
Yes.
having people inject data seems ungood.
Okay, so the comment is basically that you can use Guice and dependency injection to inject different types of things. You can inject stateless services, stateful services, and you can inject actual pieces of data. And to some people, the idea of injecting things that represent data is a little bit uncouth or seems problematic. All I can say is that to me, it works for me and I like it, and we can discuss it more offline. Okay, and who are you?
Yeah, so I just wanted to say the problem with me for using thread locals is like the same problem as with service locators or any factories. It's that it's kind of like a hidden dependency, and then the thing that makes it hard to test is I don't find out until I try and test that object, and it blows up because I get like a null pointer exception. Whereas with this, I have to pass it in. It's completely obvious. So.
So
yeah,
I'm gonna, because there's only 15 minutes left, I'm gonna try to cap off this thread, and we can discuss it, afterwards, unless you had a final thing to say, Bob.
Well, it just doesn't have the same testing.
Okay. So we think that our way has not the same testing problems, and we'll move on for now. How to choose a scope. This is not always trivial. Sometimes you have to think about it for a bit. If your object is stateless and is inexpensive, doesn't really do much when it's instantiated, then it kind of doesn't really matter what scope you put it at. Put it at whatever scope you want. Don't scope it. Make it a singleton, whatever. If your object is stateful, typically it's going to be somewhat obvious what scope it needs to live at, because your application probably wouldn't work correctly if it was at a different scope. For example, if your object is trying to maintain a count of every time a certain event happens for a particular session, then it obviously needs to be at a session scope. Things that are expensive to construct or tie up resources like a database connection. These are a good use for singleton, or maybe a singleton that manages a pool. And there is some merit to the idea of implementing a pool scope, but there isn't really baked into Guice the concept of releasing an object when you're done with it. So that's, we'd have to think about that a little bit more before I think you could implement a pool of objects as a scope per se. Another rule, like we just covered, if your object depends on something that lives at scope X, then your object had better be also scope X or narrower than that, or unscoped. Unscoped is always fine. Or use provider injection, yes. True. So if you think that you want session scoped, sometimes you really do, but also they tend to be, HTTP sessions tend to be kind of overrated and overused. Sometimes people just use them as a random cache. If you just want a random cache, why don't you just use a random cache, is our point. And other uses are really better implemented by the conversation scope that we don't actually have in Guice yet, but I thought I'd mention it anyway as a way of nagging Bob to hurry up and write that. Write that, Bob. Conversation scopes are very nice. I won't digress into talking about them right now, but if you're interested, you can ask me or Bob. Be very careful with singletons and things that are session scoped. If you're going to use them, better make them thread safe. You don't have to worry about that with things that are unscoped or things that are request scoped. But if you're going to make something a singleton, it should be thread safe. One good idea is use that jar file of annotations that was produced along with the Java concurrency and practice book. They have these annotations like @threadsafe and @immutable and @notthreadsafe. And then, you know, if you were going to type @singleton @notthreadsafe right next to each other, you'd be like, wait a minute, that looks wrong. Although, I mean, I suppose you can have a singleton that you confine to a thread somehow. I don't know. There's always exceptions, but it's just a general warning. Sometimes you think through all this stuff and you realize that you want it to be scoped, but the scope that you want it to be at doesn't exist. And then you have to write it yourself, but it's not really too bad. And you can always email the mailing list and we'll help you with that. So that's all I had on scopes. I think I only talked about scopes for half an hour. Any scope-specific questions before we spend just a few minutes on this slide? Yes, Z.
So I mentioned a couple of times, so you have the singleton scope, which is the thing that the provider gets and only provides it once and never again, which is the widest possible scope in existence. I think Guice should also bundle the narrowest possible scope in existence, where the provider always provides a new instance of that.
So if you had a scope that was defined to be the narrowest scope possible, would you allow people to have an instance injected and then hold on to that instance as a field? Because if they were to do that, they would have to also be at the same scope. Or what you would do is force them to always use provider injection. Okay, so I think Bob and I talked about this in a totally different context. It may be as simple as a scope, or it may need a little bit more funny stuff. But yeah, we'll take that into consideration for sure. Okay, so I have 10 minutes left and 3 slides left. That's not bad. I wanted to just talk about tests for a while, because at the last presentation, we showed how Guice helps your unit tests. And here I pasted in the code that we showed last time. This is an example of a strict unit test, which is also sometimes called an object test, to emphasize that it's really supposed to only test one object. And this is like a very strict, very sort of die-hard way to do all of your testing. I think that there's a very strong emphasis on object testing, because for most people in most situations, your choice is kind of either to just test one object or to end up testing this whole huge, system of things, which would make your tests slow, and we all know all the problems of slow tests. So I wanted to point out that while Guice not only encourages you to write your classes so that they can be very easily tested in absolute isolation, it's also really good at letting you define whatever set of interactions you want to test that you want, and just tell Guice to string those together and test those. And in fact, you can do this in a couple of ways. One way is you still take this same approach with the code, but instead of creating a mock displayer here, you might create a real displayer, and you might pass into that a real foo and a mock bar. So you just simply choose which things you want to draw your circle of interest around, and you create real things and mocks for everything else, pass them all into each other, string them all together, and you're good to go. And if that gets a little unwieldy, there's nothing wrong with your test case just creating a custom one-off injector to do just what your test case wants. If you want to test these 6 things and not the rest, you can create an injector that specifies those 6 things, and you can use EasyMock or write your mocks by hand for the rest of them. And it works out really well. We do a lot of that kind of testing in the team that I'm from. In fact, sometimes really I wanted to bring attention to those tests because oftentimes when you're unit testing, you're testing at such a low level, at such a granular level, that ultimately what you're doing is just encoding the same information that's in your production class in a different way. And I'm not saying that there's no value in that, but when you can string together a little bit more meat on the bone to test, then you have a little bit more meat behind your test, if that makes any sense. Guice also is also helpful when talking about your functional tests. If your project is anything like mine, your server in production probably depends on a lot of other servers. It might contact 20 different servers for 20 different purposes, LDAP, you know, you name it, whatever. Services, you know what I'm talking about. And so what usually ends up happening is you have like test servers set up, and every time you run your functional tests, it's actually creating sockets all over the place, talking to all these different test services. And if those test services go down, then your tests are inoperable. And if there's some bug in their code, it shows up as a problem in your tests. So what Guice does is it sort of gives you a nice way to make sure that every time that you do anything that opens a socket to some other service, you have that behind an interface, and you have a mock or a fake for that interface. And just as you have an application defined that puts together this list of 78 modules or whatever that's your production application, you can put together some of those same modules with some alternate modules that specify these mocks instead, and you can use that for some of your testing. So you can say, you know, I want to run the tests that just encompass my server, my runtime environment, that mock out or fake out all these external services that I depend on, and my test will run a lot faster and be a lot more isolated. And it doesn't stop you from being able to also just go and run using the other file that specifies the full integration of everything. And this is because of the nice many-to-many relationship between your modules and your applications that Guice gives you. Does that make any sense? Any questions about that? Just like a mini rant that I wanted to work in. So in the final minutes, here are some tantalizing glimpses of features that we're working on. Don't read ahead now. So one thing is provider methods. So right now, if you want to specify a custom provider, you have to implement the provider interface and write a method called get. But that means that a single object can only serve as a provider for one other thing, because you can only have one get method. So what we're doing instead, you can have as many methods as you want. You put an annotation on those methods that says @provides. And that actually gives you a much cleaner way to do a lot of bindings, because if you want that binding to be at session scope, you just say @provides @session scoped. And if you want it to only be bound when you use the @blue annotation, you just say @provides @blue @session scoped on your provider method. So it's very clean. We'll cut down a lot of the bulk from your module classes. Yes, question?
One thing I've run into is that I find myself still writing factories because some of the arguments are actually data, and the problem with the provider interface is that you call get and it takes no arguments. Are you thinking of like adding arguments to provider
Are we
methods?
thinking of adding arguments to the get interface, or some ability to have arguments? We're not planning on doing that because we have so far had not much trouble with the pattern that you basically, if you need 2 parameters, you have an interface that takes those 2 parameters. The implementation of that can have the injectable things that it needs injected. And then the code that needs the ultimate instance and has those 2 parameters, has this thing injected, passes in the 2 parameters, gets what it wants. If that is becoming cumbersome, again, like email the mailing list, show examples of code, like convince us of this repeating pattern that's bulking up code all over the place, and we'll keep thinking about it.
It's working well as it is, so I was just wondering if
anything that we can get people to say is working well as it is, we'll probably try to keep the same. Next question. Okay, so we also have are working on construction listeners. and can barely even touch on all the power that will be exposed by this, but essentially you can attach listeners that get notified whenever Guice constructs an object, and then you can perform your own post actions on that. So if you want to, fulfill like the EJB style annotations like @resource and things like that, you can just write some code that handles that and attach it, and now suddenly Guice will behave as if it's a completely different style of container. Did I just say container? I said container. Another thing is multi-bindings. So what we want to allow you to do is bind a collection, which only has to be an empty collection, but then other modules, as many different modules as want to, can contribute bindings which will become elements of that collection. So if you imagine servlets, for instance, maybe you have 8 different modules that want to add some servlets. They can all bind as many of these servlets as they want. And when you ask to have the list injected, Guice would walk down the list and get the instance for each one, put them together into your collection, and inject them into you. And this is actually going to come in useful for a lot of things that we're doing. And auto binders, too hard to explain. I'm going to pass over it, but it's cool. And it may not happen with the next release, maybe the one after that. And the introspection API, right now, if you get an injector, you can get a few rudimentary things from it, iterate through the keys and the bindings. We're going to expose every detail about the dependency graph through this API so that we can support tools that can draw charts and graphs and who knows what kind of stuff, do validations for you, try to calculate a more optimal startup order that we can tell Guice to use, who knows what. We're just going to expose the information about that graph directly on the API. And the other things may miss the release, but they're in the works. Question in the back.
Sounds like a thread local singleton scope would be useful.
Thread local singleton scope is kind of like, you could also just call it thread scope, I guess. And I think that first of all, if you want to implement that scope, it would be very easy to do. Typically, what that means is that for the entire life of that thread, that same scope is alive. And if you have anything where you're thinking, well, periodically, it has to be zeroed out so that from then on it can be a new thing, well, then that's really a different scope that, that's more like a request scope.
Well, I was thinking of if you have open a socket or something to some other service and you don't want to go through and make it thread safe and you'd rather have each worker thread have its own copy of that structure.
Okay, so it's sort of one way of doing like a pool, just say, hey, 1 per thread. I can see that. I can also see if God help you, you're stuck using simple date format, it'd be nice to just stick simple date format in a thread scope so you don't have to deal with the fact that it's horrible. So yeah, we'll think about whether a thread scope belongs in Guice, but it's also pretty easy for you to add. Any other questions? Thanks for coming, everyone.